sphere is basically like a ball or a marble, right? Like a circle is what you see at the center, but then it's like a complete ball. The volume is 4 by 3 pi r cube, so it is like this. In all dimensions, it's the radius r. Any point on the sphere I take and I join to the center, it will be all radius r. So pi r, so it's only one element that you need to know, radius. So the volume is 4 by 3 pi r cube. The surface area is 4 pi r square. So there's nothing written as curved surface area, total surface area. For a sphere, it's all the same. Curved surface area, total surface area. I don't have any base that is being exposed here. So curved surface area is 4 pi r square. If the total surface area is also curved surface area plus area of the bases, which is 0 because there is no base per se for this. So it will still be the same 4 pi r square. Keep that in mind, right? There's no difference between curved surface area, total surface area, simply see surface area. All of this is same. Hemisphere is nothing but half the sphere, right? So this is complete sphere. So the same circle what we're seeing, the hemisphere would look like this, right? So it's basically half the sphere. I just need to, let me put it like this, right? If I put like a plane, I cut it like this, half, it's cut into half. So I have two spheres, sorry, two hemispheres make a sphere like this. So that's why automatically the volume will become half of the sphere. The sphere is 4 by 3 pi r cube. So hemisphere is half of it. So that's basically 2 by 3 pi r cube. The curved surface area would also work out the same. The entire sphere is 4 pi r square. That the entire sphere is, all the side curved part. If I do half of it, that will be 2 pi r square. When it comes to total surface area, this part is all 2 pi r square, okay? That's fine. What about the new circular base that is opened up now? Now the hemisphere is having a circular base. The sphere did not have any base, but hemisphere has circular base, which is pi r square. So I need to add 2 pi r square plus pi r square. So that's why it is 3 pi r square, right? That's why you have formulas for separate formula for curved surface area of hemisphere and total surface area of a hemisphere. Simply these are the formulas that you need to remember. Altogether the shapes that we discussed. Once you remember the formulas well, it's all about applying them in the formulas directly. There's not much of complication involved in this. So a solid sphere of 6 cm diameter is melted and recast into 8 solid spheres of equal volume. The radius of each small sphere is. So this question, these type of questions, basically you have to follow a simple logic that volume of a big shape is equals to the volume of small. If all of small shapes are same, I just need to multiply with n such small shapes, right? Here it says recast into 8 solid spheres of equal volume. All the small spheres are same volume. It's just that they are 8 in number. So I know that this is 8, right? I need to know the volume of the small sphere so that I can figure out the radius of the small sphere. The volume of big sphere can be found out from the given value that solid sphere is 6 centimeters in diameter, right? If 6 centimeters diameter, what is the radius of the big? Let me call it big R. Is 3. What is the formula for sphere? 4 by 3 pi r cube is equals to, I don't know the volume of small cube, so let me assume it to be r small r into 8 because I have n such 8 such small, right? So volume of each small sphere is 4 by 3 pi r cube, so I can find the small radius r into there are 8 such. Combination of all of this should be equal to the bigger one because that's how we made those 8 spheres, right? So volumes should be equated like this. 4 by 3 pi get cancelled out. R cube is this 3 cube, that's 27, is equals to r cube into 8. 8 comes this side, that's 27 by 8 is r cube. R is 3 by 2 from this, so that is 1.5 centimeters. So the answer is 1.5, right? Only thing, one type of question you get to see is there is one figure, 3D figure, it's melted and recasted into another figure. All you need to do is figure out, just stick to this formula, volumes are equal. So volume of first figure should be equal to volume of figure 2 and then you can find whatever is required and then solve the question. Other type is that I have bigger figure, I make them into small, n such small figures. So I need to do this one. Bigger figure equals to the volume of bigger figure equals to n into volume of small figure, and n is the number of such small figures that are made from the given bigger figure. So this is what I applied here to find the radius which is being asked, right? So all the things that you need to do in this concept, in 3D geometry, is just know the formulas properly and solve a couple of problems for each type, and then you'll remember the formulas and you can solve the questions in easy manner. There's nothing much to be complicated or ask beyond a certain point in this area. So it's definitely a good area to focus on to score well